Hello everyone. In this video we will discuss about instrumentation cable. So in couple of videos what we will learn, we will discuss about introduction of instrument cable, types of cable used in instrument department, selection criteria of cables, applicable standards, cable constructions, cross-section view of cable, AWG to conversion, what is fire resistance and flame retardant cables, electrical properties of cables, cable technical specification preparations for purchasing, and thermocouple cables, RTD cables, communications cables. And then we will discuss about installation and handling procedure of cables. And at last we will discuss about reputed supplier. So in right side video you can see this is the a figure of cables having different parts are showing. So what is instrument cable? Instrument cable are physical medium of flow of signal of power from instrument to the control system and control system to instrument. Mostly instrument cable operate at 24 to 1110 voltage and 420 milliampere current rating. So in right side figure you can see these are the field instruments and the signal is going toward the junction box, and from the junction box it is going toward the control room. So this signal is flowing through the cables. So different cables can be used from different field devices. Further, from the junction box all the cables can combined and only one multi-pair cable can go towards the control room. There are different types of cable can be used in instrumentation department based on the applications: signal cable, control cable, power cable, thermocouple cable, RTD cable, optical fiber communication cable, Ethernet communication cables are there. Based on the number of cores, core cable like 1 core, 2 core, 3 core and so on, and pair cable or multi-pair cable like 1 pair, 2 pair, 3 pair and so on cables can be used. Triad cable for RTD like 1 triad, 2 triad, 3 triad, these types of cables can be used. And all these core, pair, triad cable can be used with individual or overall sheath or without individual or overall sheath. If we talk about the hazardous area, then based on the hazardous area also we can classify the cables like IS cable, non-IS cable, fire resistance and flame retardant cable. And if we talk about the insulation, then different insulations are available. So basically insulation is for protection of cable. So for different environmental conditions or temperature there are different types of insulations available. So like XLPE, PVC, PE, halogen free, EPR, different types of insulations are available. So based on these criteria we can define the types of cables. Selection criteria of cables. So before selecting a cables, following things we need to check, like physical requirement. So length tolerance, diameter tolerance, or all tensile strength, weight limitations, minimum bend radius. These are the physical requirement about the cables we need to check before the selection. And the environmental requirement also based on the site conditions. Again the electrical requirement like voltage rating of the conductor insulations, maximum current expected in the conductor, amount of electrical or magnetic shielding requirement, capacitance requirement, voltage drop acceptable. These are the electrical requirement can be there. Also some other informations like area classification, applicable standards, color coding, clients requirement, soil study. So these are also some data before the selection of cable we need to check and verify. Codes and standards. So for cables there are so many standards are applicable. So basically we use either British standards or international standards. So these are the British standards applicable for the cables. So for conductor it is EN60228, for insulation it is EN50290, for shielding it is BS50288, and for sheath like inner or outer sheath it is EN50290. For armoring it is BS50288. So these are the standards which are used in cable selection and cable technical informations. Cable constructions. This is very important part of cables because these sections will provide all the information about the cable constructions. So in this figure you can see there are different parts of cables. So what are the major parts? It's conductor, then insulation, and then individual shielding and screening, and then overall shielding and screening, inner sheath, armoring, and outer sheath. These are the major part of the cable. So let's talk about the conductor. So there are so many types of conductors constructions. Normally there are three classes: class 1, class 2, and class 5. So in class 1, the only conductor is made for only wire is of 1.5 square mm conductor. There will be only one wire of 1.3 mm diameter, and it is denoted as 1 by 1.38 mm. The problem is with this wire that the bending radius is very big, so we cannot bend this wire in small radius. The second class is called stranded wire. The conductor is made of several wires that is called as strands laid up together. Here is 6 strands are laid up around the one central strand. So total 7 number of strands will be there. So for 1.5 square mm conductor there will be 7 strands of 0.53 mm diameter of each strand, and it is denoted as 7 by 0.53 mm. And the class 5 is flexible wire. The conductor is made of several twisted together in one directions. So basically that is 1.5 square mm. There will be 30 number of wire of 2.25 mm diameter each, and it is denoted by 30 by 0.25 mm. So if you talk about then solid construction of the wire will be very less efficient or very less recommended. So basically in this oil and gas or EPC sector industries, either we can use of stranded and or bunched wire. So most of the cases we use stranded wire because it is best for the construction, best for the installations purpose. If we talk about the material of conductor, then mostly or you can say in maximum conditions we use the copper wire, because if you see the table where electrical resistivity and thermal conductivity, so the top one is the silver wire. However, this silver wire is most costly over the other types of material, so we use normally copper wire because it's have very good conductivity and very low resistivity. So normally you can see in industries copper wire is used. Again the insulation, which is the insulation is the part of this cable construction. So you can see PE, XL, PEP, PVC, halogen free, cross link, halogen free, EPR, silicon, different types of insulations are available. So what is the insulation? So the coating over the conductor, which includes insulate it's from outer conductor or other conductor. So that means if you have two conductors, so how you will insulate each other conductors? So you have to insulate a different types of material, that is basically separate one conductor to other. So this is called insulation. There are different types of insulations are there. So what is the good quality of a good insulations? Like it's a good electrical property, better heat stability, should not be affected by normal environmental conditions, it should have flexibility, it should have regional price. So basically a best insulation have these types of properties. So the considering the above insulations material can be divided into two classes. One is thermoplastic and second one is thermosets. So basically the thermoplastic material, when these materials can be heated, then their molecule chain drifted apart and become soft due to the temperature and regain their original shape on cooling. So these are the material like PVC, polyethylene, polypropylene and new generation of low smoke zero halogen are the thermoplastic materials and cannot be used at higher temperature. They can be recycled number of times. There is a nylon is a polyolefin material and can be used for higher temperature as well tough applications. So these are the thermoplastic insulations. What is the thermosetting insulations material? So these are the plastic and rubber. When initially heated, their linear molecules chain get interlinked, and this it is not reversible. Due to this phenomena, they can be operated at higher temperatures like vulcanized rubber, cross-linked polyethylene, silicones rubber, other types of rubber such as EPR, EVA are the thermosetting materials and they cannot be recycled. Several types of insulations materials are there like PVC, polyvinyl chloride, LDPE, low density polyurethane, and XLPE, cross-linked polyethylene, and FEP and PTFE, ethylene propylene rubber, that is EPR, and silicon. These types of material can be used, but in normal cases you can see normally we use PVC because our environmental condition is not much higher than the 70 degrees centigrade, so polyvinyl chloride is better. And for the higher applications like control or power cables, we can use the XLPE cables. So what is PVC cables? So this is most widely used plastic due to its versatility. Unlike other plastic, cannot be used alone. It is required to be mixed with other ingredients like plasticizers, filters, stabilizers, lubricant, etc. to make the workable. By varying the ingredient, their proportion in compound and end property can be varied to get extent to meet the specific requirement. The normal PVC insulated cables are suitable for continuous 70-degree operations. By changing the plasticizers and stabilizer, we can have the HRPVC, which is suitable for continuous 85-degree operations. Due to higher dielectric constant and hence higher mutual capacitance, it is not suitable for operation above audio frequency, that is 20 kilohertz. But normally we can use the PVC insulated cables for our all the signal cables. And low density polyethylene LDP cables, this is has got excellent electrical property, but it is suitable for continuous 60-degree Celsius operations, and hence it is not used for power cable. Due to its low dielectric constant, it is widely used for telephone and radio frequency cables. And then cross-linked polyethylene XLPE cable. Cross-linked polyethylene meeting the ICEA S 82252 standards can withstand higher temperature of 90 degree due to cross-linking of ethylene chains, and hence it is widely used for LT and HT power cables XLPE capable for withstanding of 105 degrees centigrade to 125 degrees centigrade conductor temperature can also be offered. And then FEP and PTFE are the plastic which can be used for insulating material of higher temperature application of 200 degrees centigrade. EPR rubber is the common synthetic rubber polymer used as an insulation in electrical wire and cable and control instrumentation cable. Similarly, silicon is the soft rubbery insulation that can be used from -80 degree to 200 degrees centigrade. Again, cable construction for screening and ripcord. So we have heard about the screening or shielding informations. So sometimes we can heard like the individual shielding or overall shielding. So basically in some cases we use the individual shielding, and in some cases we use the overall shielding. In some cases we can use individual and overall shielding. Also in some cases we can use without shield. So here are the different types of screening or shieldings philosophies available. Normally, to prevent the interference with the cable signals, we use the screening. So what we can use? We can use either single individual screening or overall screening, or both, or without screening. What are the material are used for the shielding purpose? Aluminium, copper, polyester, bare copper braided, tin copper braided. So you can see in the right side there are the different types of material, and its screening is available. Most commonly is aluminium shielding, which are used in our instrumentation cable. So as I told you that the screening or shielding is required to eliminate the interference, like sometimes the interference with the noise in the cable, that can be electrical cables which is going in parallel to the instrumentation cable, or sometimes crossed from the crosstalk from the adjacent pair of triad. So this could be the interference. So the screening or shielding will be eliminate these types of interference signals. And the nylon ripcord is used for the providing sufficient strength along the cable so that the inner sheath cannot be damaged. While removal of inner sheath, it cannot damage, it will prevent to damage the inner sheath. Again, the inner sheath and armoring. Inner sheath, if you talk about the inner sheath, then you can see in the picture, this is the inner sheath. So this is the conductor, this is the insulation, blue and white insulation, and then this is the screening. Again, this is the inner sheath material. So P, PVC, HR, FR, FRLS, rubber, EVA, LSOH, these types of inner sheath material. So what is the inner sheath material? It is of PVC, either extruded tape, to provide the overall shield as the bedding for the shield, and armor to avoid the common mode interference. Extruded sheath also add to the circularity of the cables. Taped inner sheath is not recommended as it is not impermeable, and in the case of any puncture in the outer sheath, the water reached right to up to the sheathing and corrode it. And armoring, it is very important. Armoring is providing over the inner sheath when the cable have to install in direct buried for mechanical protection. It is conductance is not importance in instrumentation cables, and it is in power cables where it has to carry heavy earth return current in case of short circuit. Steel armoring is also provide the protection against electromagnetic interference due to its magnetic nature, and it also provides the protection to inside cable against the rodent attack, which is quite common in tropical countries like in India. The following points must be considered while considering the armoring, like what is the required tensile load, what is the minimum required bending radius, protection against the rodent attack, protection against accidental and external damage, expected pressure on cable during the service. So different types of armoring is available in right side. You can see this is the armoring types like GSFA, SWA, and RWA, GSWB, and GSTA. So basically, if you talk about the general language, then two types of armoring is there. One is the round wire armoring, and second one is the plate, or you can see sheet armoring. So basically, if we consider the sheet armoring, then the bending radius will be more, and if we consider the round wire armoring, then the bending radius will be less. So basically, for small diameter cables, we use the round wire armoring, and for the heavier or outer diameter cable, we can use the sheath, or you can see plate armoring. Outer sheath. So the coating on the armoring is known as outer sheath. Many compounds can be used as sheath material. The different grades are available to meet the specific working condition. The below factor affect the sheath material, like better abrasion resistance, type of insulations like outdoor, indoor, or direct buried, possible presence of humidity, oil, chemical, etc., behavior in case of fire, range of temperature, better weatherproof property. So basically, outer sheath is the part of the cable which is directly touch with the environment and the like soil, temperature, weather conditions. So its material is very important with respect to environmental conditions. There are the few materials which can be used as outer sheath, like zero halogen fire retardant cables, and polyethylene outer sheath, nylon polyethylene sheath. These types of material can be used for specific conditions. Color of the outer sheaths. So by default it is black, as it is part weatherproof properties. In case of cable used for intrinsically safe system, the blue sheath is provided. Sometimes clients specify the gray or red sheath to differentiate the instrumentation cable from the normal cable. So this color is also very important. Again, the cable cross-sectional view. So if you cut the cable from the front, then you can see the different types of cross-sectional view for different types of cable, like for one pair, two pair, four pair, different types of pair you can use. So here is few examples which provides you a clear picture about the cables. So first picture is for 4 pair overall shield and unarmored cable. So this is the unarmored cables where the 4 pair cable is there. So if you see, the 4 red wires are there and 4 blue wires are there. So 4 means total 4 pairs are there. And this is the this is the drain wire, is the black dot is showing the drain wire, and all these 4 pair cable and drain wire is in single inner sheath, and there is a overall shielding for all 4 pair cables. Again, if you see the 4 pair overall and round armored cables, so this is the 4 pair cable. Again, this is the drain wire, and this is the round. This is the armoring for round wire armoring. Again, this is the 4 pair individual and overall shield. So you can see each pair have the shielding, and a complete all 4 pair have also the shielding. So this is the individual and overall shielding, and each pair have a drain wire also. So this is the difference between individual shielding and overall shielding. This have overall shielding, this have the overall shielding, and this have the individual and overall shielding. This is the 12 triad cable. So basically for one triad there is a 3 wire required. So for 12 triad, 12 into 3 cables will be there, but for one each triad we have a individual shielding. So these types of arrangement will be there. So you can see twisted triad cables with drain wire and individual and overall shielding is there, but this is unarmored. So again here you can see this is the stripped armor. Earlier I told you about this is the plate armoring or sheath armoring, but in other language you can see this is the metallic strip. So 12 triad with overall shield with metallic strip armored cables. This is the 6 core overall shielded unarmored cable. So this is the 6 core cables with drain wire, and this is the 6 core overall shielded armored cable. This is the round wire armoring is there. Again this is the 12 pair cable, and this is the 24 core cables. So basically if you talk about the core cable and pair cable, then the cost wise pair cable is more costly than the core cable. But if you see the difference between the core cable and pair cable is that the outer diameter of core cable is small as compared to pair cable, because 12 pair have also 24 core and 24 core itself 24 core. But if you talk about the outer diameter, then the 24 core have the outer diameter small than the 12 pair cable. There is a general questions asked every time about the AWG. What is the AWG? What is the meaning of it and what is the use of it? So basically AWG is known as American wire gauge. So basically this denote the cable conductor size. The larger number of the AWG, that means smaller the conductor size. So in other language, if the AWG is smaller, then the conductor size is bigger. So there is a table which can provide you the information about AWG versus square mm cable, and this is the graph which represent the maximum breaking strength versus size of the conductor in AWG. So the AWG is smaller than the maximum breaking strength is greater. So we recommend the smaller AWG. If you see the table, then for the 20 AWG cables have 0.5 mm square conductor, and if you reduce the AWG to 18, then the conductor size will increase up to the 0.75 mm square. Again if you go to the 16 AWG, then its conductor size will be go to the 1.5 mm square. So that means decreasing the AWG value means increasing the conductor size. That means decreasing the resistivity and increasing the conductivity. So this is about the AWG. Rest of the part of the cables we will see in next video.